Hello everyone. Today we will be discussing Leetcode Biweekly contest 131's solutions. Here I will be explaining my approaches to solve these four problems. First we will start with the first one. So here you are given an array nums where each number is in the array appears either once or twice. You need to return the bitwise XOR of all the numbers that appears twice in the array, or 0 if no numbers appear twice. So it's a quite easy problem to do this. Like let's say let's consider the sample test case to understand this problem. 1 2 1 3. Let's say we have an array nums nums 1 2 1 3. So as you can see here, 1 repeats twice. So what we can do, we can the answer will be 1 XOR 1, which is equal to 0. So basically, like, you need to take XOR sorry. So basically, like, you need to this is wrong. Basically you need to take XOR of those elements which appears twice. Here the only element which appears twice is 1. Let's take another sample test case. Let's take 1 2 2 1. So here as you can see, 1 appears twice and 2 appears twice as well. So answer will be 1 XOR 2, which will be 3. So answer is 3. So how to solve this problem? It's pretty simple. The constraints are so you can see the length of the nums is 50 and the value of the elements in the array is also less than 50. So basically you can take an array of size 51 with indexes from 0 to 50, and you can, like, boolean array, you can take a boolean array and initially it is false. If you see a element first time, you will be like setting it true. If you see a element second time, which can be like easily verified from by checking whether the value in this array is true or not. If it is true, it is already visited. So basically you will be taking XOR of all the visited elements. So how we can implement this? We will be taking an array of size 51 with all initial values false, answers 0 initially. So if let's say the element is already, like, we have seen that element, we'll be taking XOR with our answers. Otherwise, like, always we will be setting true. So if an element is seen already, the visited of X will be true. So we'll be taking XOR of all the repeated values. That's how we will solve this problem. Moving on to next problem. Okay, so next problem, we are given an array nums and some queries and an integer X. In query I, you need to basically find index of the query ith occurrence of X in nums array. So I will explain this problem. Let's take this sample test case. So we have nums array equal to 1317, and then queries equal to 1324, x is 1. So basically, let's say I need to answer the second query. So what I need to do is that I need to find third occurrence of the x in the nums array. So as you can see here, there are only two occurrences of one, third occurrence is not there, so here you will be printing -1. So similarly, if you answer for all the queries, the answer array would be first element occurs at position 0, 0, 1, 2, 3. These are the indices of the nums array. So first x value occurs at 0th index, third x value doesn't occur, second x value occurs at index 2, fourth x value doesn't occur, so -1. So as you can see, that is the answer for our this input. To solve this problem, we can basically do a traversal. We have this nums array. Here this nums array 1317. So basically, you can take another array called position. In this array, we will be traversing the nums array. Whenever we find element x, we will be pushing the index of the x. So we will be traversing 1317. X occurs at position 0 and x occurs at position 2. Now we will be answering. Now this array is sufficient to answer the queries. How? Let's say if our queries of I, this value is greater than size of our position array, then you can print -1. Otherwise, else you can just print position of queries of I -1. This -1 is for 0 indexing. So that's how we will solve this problem. This one is also pretty simple. Let's move on to third one. Okay, so third one, you are given limit plus one number of balls with the distinct labels from 0 to limit, and for every query is in the form of x, y, where you need to mark the ball x with color y. After each query, you need to also print basically find the number of distinct colors among the balls. That you need to store in the result array after each query. Okay, so to solve this problem, basically we'll be taking two maps. I will explain. So to solve this problem, we will be taking two map. First map will be in the form of ball number maps to color of the ball. Map 2 will be color and how many, basically count of balls of that color. So we'll be having these two maps. With these two maps actually we can solve this problem. So in our question, let's take this input, first input, limit equal to 4, limit equal to 4, queries are one comma 4, 2 comma 5, 1 comma 3, 3 comma 4. These are the queries. So initially both the maps will be empty. Map 1 will be empty, map 2 will be empty. Okay, so we will be first we will process we will be processing query one by one, and simultaneously we will be finding answers for the query from these two maps. So first, like, the first ball is set to color 4. So here I will see in the first map whether the ball 1, whether we have colored the ball 1 earlier. We haven't colored the ball 1, so we will be just entering this entry 1 maps to 4, and we will be increasing the color count of 4, which is initially 0, which is increased to 1. Now, like, our answer will be basically the size of map 2 after the ith operation. The thing is, like, in map 2 we will be maintaining the non-zero color counts, basically the color which have non-zero number of balls. Let's say color C will be in a map 2 only if number of balls with color C is non-zero. So we will be maintaining non-zero colors, count of non-zero colors. So it will be simply answer will be simply number of distinct color, which is size of map 2, which in this case it is 1. Let's process second query 2 comma 5. 2 is not there in we haven't colored ball 2, so we will just insert 2 maps to 5, and color 5 gets increased its count to 1. Now the number of elements in map 2 is 2, so the answer will for the second query will be 2. Number of distinct color will be 2. Next we will be processing the third query, which is 1 comma 3. Now element 1 is already colored. Now we are recoloring it. So what we will do in this case is we will be taking the previous color of 1, we will be reducing it by 1, which it becomes 0. If a color becomes count of a color becomes 0, we will be removing it from map 2, and now we will be changing the color of first ball to third ball. Now in this case the number of elements in map 2 is 1. One minute. Once we change the color of first ball to 3, the color count of 3 will be increased to 1. So here in map 2 we have 2 elements, basically 2 distinct colors. So answer for the second query will be 2. Next we will be processing the third query. In fourth query 3 comma 4, we haven't colored third ball earlier, so we will be just inserting it 3 to 5. Now color count of fifth will be increased to 2. Yeah, so color count no third ball has a fourth color 4, so it will be color 4. Sorry, it will be color 4, and here the count of fourth one will be increased to 1. So in map 2 basically we have 3 distinct elements, 3 distinct color. So answer for the fourth query will be 3. So this is our answer. So likewise you can same thing, if you code you will be getting the answer. So basically we took 2 maps, color and count. We are traversing the query one by one, and if the ball is already colored, then we will be decreasing the color count of the previous color. If it is 0, we will be erasing that color, will be changing the color of the ball, and then we will be increasing the count of the new color of the ball. Now if it is not there, if the ball is not already colored, we will color it newly by setting the color of the ball to be the color and increasing the count of the color. Now each time after processing the query, we will be pushing the size of the count map. Basically it gives the number of distinct colors after each query. So this is how you solve the third problem. Now fourth problem. In fourth problem, where you have an infinite line with origin 0 extending towards positive x-axis. Now you are given a query, like it will be of 2 types. First one will be of 1, x, second one will be of 2, x, size. So if it is 1, x, then you need to build an obstacle at position x from origin, and they are guaranteeing that there will be no obstacle at distance x while building x. Like basically 2 obstacles won't be there in same place, and you need to check whether is it possible in second query, whether you need to check it is possible to is it possible to place an object of size sz between any position between 0 to x, such that the obstacle won't be intersecting the block won't be you need to place a block entirely in the range 0, x, such that the block won't be intersecting with any obstacle. It might touch it, but it shouldn't intersect. So you need to return a result array with true if you can place the block, false if you can't. One more thing is that you are not actually placing the block, you are just checking whether you can place or not each time. So let's take second example. So you have queries 1, 7, 2, 7, 6, 1, 2, 2, 7, 5, 2, 7. So we have these. So like we have the number line starting from 0 going towards the right side. Let's process the first query. We need to place an obstacle at 7. So we placed an obstacle at 7. In second query, we need to check whether we can place an object of size 6 within the range of 0 to 7 without intersect. We need to place a block of size 6 within 0 to 7 without intersecting obstacle. So obviously you can place a block of size 6. Already we have 7. The length of this range is 7, so you can easily place block of size 6. Next query, so answer for this query will be true. So answer for the second type query will be true. Next, first type query, you need to place a block obstacle at position 2. Here it is. Now this whole segment will be divided into 2 and 5. Now again, type 2 query, from 0 to 7 you need to check whether you can place a block of size 1. Definitely you can place here and here as well. You can place, enough places is there. In last one, it's a type 2 query. It's a query from 0 to 7, and you need to check whether you can place a block of size 6. As you can see, the segment size is 2, 5. Maximum of 2, 5 is 5, which is less than 6. So obviously you can place it. So answer for this will be false. So it will be true, true, false. That's what the answer mentioned here as well. So how to solve this problem? We can solve this problem by using a set and then segment tree. So what we will be doing is, okay, in the constraint it is given that the x value doesn't exceed 5 into 10 power 4. So whatever points we are handling will be within the range of 0 to 5 into 10 power 4. So we'll be taking an array of size size 5 into 10 power 4 plus 1. That's for the indexing 1 2 3 up to, let's say n, capital N equal to 5 into 10 e power 4. So from 0 to n you should construct an array of size n plus 1. So the ith element, let's say this, let's call this array as let's say segment size, or let's say free. So what free of I, the ith value of free is basically is the maximum block that you can place with ending of the block as I. So in coordinate, in the number line, let's say we have a point I. So the free of I tells what is the maximum size of the block that you can keep where block ends at I. The ending of the block is ith coordinate. So you'll be trying to build this array. So how can we build this array? So we'll be maintaining a set of integers. Initially this set will be containing boundaries of the array, which will be 0 and n, which is 5 into 10 power 4 plus 1. So these are boundaries of the array. Now for each type 1 query where we will be placing an obstacle, so what we will do is that, for let's say this is the number line. Let's say you have received a query of this form 1, I. So you need to place an obstacle at I. Let's say some distance before I there is another obstacle, let's call it I previous, and some distance ahead you have another obstacle I next. Now let's say like initially the value of the free, the initial value of free will be, for the 0th index it will be 0, for first index it will be 1, for the second index it will be 2, up to so on. For the last index n plus nth index it will be n, for nth index it will be n, because you haven't placed any obstacle yet. So let's say you have at this point, let's say we have our updated free value. While inserting I, basically like for each insertion of obstacle we will be updating our free array. So how we can update is that after inserting this obstacle I, the elements that are before the I, before the array value before I, before the ith index won't be changing, because the block ends, because the free of I is basically the maximum size of the block that you can keep, where I is the ending of the block. So it doesn't really matter if you place an obstacle after I. So value of I before the value of value of the free array before the index I won't change. Even value at index I won't change. What actually changes is that value at this region from I plus 1 to I next, this changes, and those which are ahead of I next, indexes greater than I next, even those won't be changing, because you already have an obstacle over here. So adding an obstacle before an obstacle won't change the answer of the this region. So indices after I next, for those also value of free won't be changing. Indices before I including I, for these indices also the value of free won't be changing. So only region where the value of free changes is from I plus 1 to I next. I next is basically immediate obstacle ahead of I. So to query I, so how it will change, let's see how the values of free from I plus 1 to I next will change. So on adding an obstacle I, let's consider an example. initially we'll be having these values in free array. Let's add an let's say there's an obstacle. Let's increase a bit more. Let's say there is an obstacle at first index. Let's say there's an obstacle at first index and there is an obstacle at fifth index. So the value of the free array will be one, two, three, 4. Yeah. So we have a obstacle at 1 and 5. So the free array will be looking something like this. Let's say I need to add an obstacle at 3. So what we will be doing, or how will this change? So from the I previous, which is I, this is I previous till I. So what happens is that basically, like this region, the value of free in this region 3 and 5 will be changing. The indices ahead of 5 won't be changing because there is already an obstacle at 5, so those won't be changing. And value of free before or equal to index I, those are also not changing. The only changing part is index 4 and 5. So how much it will be changing is that, so if we place an obstacle at 3, so these two you can't like extend. Let's say I will initially if I place a block ending at 4, it can be of size 1, 2 or 3. Now if I place an obstacle at index 3, now like if I place a block ending at index 4, it can't be extended more than size of 1. It will be intersecting the new obstacle at position 3. So basically we need to subtract the free values by size of this interval between I previous and current I, basically I minus I previous. This is what we need to subtract from the free value of free value for the indices from I plus 1 to I next. If you just subtract that, our free values will be getting updated. So how we will be subtracting that? We can subtract it by using a segment tree with range updation. So you can do this. And one more thing, like how actually we can use this free array to answer second type of query is that, let's say you have been given a query of this form 2, x, sz. So what basically they are asking is that, is it possible to place a block of size sz within the range 0, x? So what actually you can do is that you can consider the maximum value of free from 0 till x, maximum value of free from 0 to x, whether this whether this maximum value is greater than or equal to my size. Whether I can whether I can find a segment, free segment, whose size is greater than is it. If it is greater, then I can place, otherwise I can't. As simple as that. So basically we need to do a range query, range minimum query from 0 to x for the free array, and also we need to do a range updation, basically range subtraction from I plus 1 to I next. So with these things actually we can answer the second query. For finding I previous and I next, you can use the set where I have stored all the obstacles. How we can do is that, let's say you store a set OBS which has all the positions of the obstacle that you have already visited. Now you will be doing an upper bound on x. X is the new obstacle that you are going to insert, position of the new obstacle. Now let's say this iterator is IT. Now previous of IT, previous position will be the I previous. The upper bound itself will be the I next. So that's how you will calculate I previous and I next. Once you have I previous and I next, you can update in the segment tree as follows. Basically, like for type 1 query, which is of 1 comma x, so you will be finding I previous and I next for the x from the obstacle set where you maintain all the positions of the previously placed obstacles. You find this. After finding this, you will be having these two, I previous and I next. From this you can calculate the updation value, the value that you need to update. Like you need to update values of free from I plus 1 to I next, because those are the values that will be changing, and that will be changing by an value of I minus I previous. So basically this value I minus I previous need to be subtracted from all the values of from I plus 1 to I next. You need to subtract this value from this can be done by maintaining a segment tree. So this is basically a segment tree range update. You can do a lazy propagation. So type 1 query is done. For type 2 query, you will be the query is of form 2 comma x comma size. For this one you will be doing a range minimum query from 0 to x, and just check whether this is greater than or equal to size. If it is true, then your answer will be true, otherwise it will be false. And also initialize the segment tree, like segment tree, the array should be, the free array should be initialized like this: 0 1 2 3 4 5. So you need to do that while building the segment tree. Yeah, so once all these things are done, you can answer the queries as follows. The time complexity of this one will be, the answering this type of query will be log of capital N, where capital N is the maximum size of the coordinate. And for answering this type of query, it will be order of log n for querying the set twice for I next and I previous, and then a segment tree updation query which again takes log n. So overall it is O of log n. So the overall complexity will be order of q into log of n, where q is number of queries, n is the maximum coordinate. So both are around 10 power 4, 5 into 10 power 4. So it will easily pass. We will see the code now. In the code I have initialize the segment tree, and then for propagation, this is for propagation. Yeah, basically you can implement segment tree with lazy propagation, where the range query should give you minimum and range update is subtraction. That's it. And then yeah, so for each query, for type 1 query, you will be finding an upper bound from the previously placed obstacles. The previous of the upper bound will be the I previous, the upper bound itself will be the I next. You will be getting the length, the number of elements between I previous and the I, basically like the previous, the position of newly placing obstacle and the obstacle just previous to it. So you need to get all the elements between these two, that will be x minus l, and then you will be subtracting those from the values of the segment tree from index, from the index where you the position where you are going to place the obstacle +1 till the immediately next available obstacle. So you will be updating that in the segment tree, and then you will be inserting this newly placed obstacle in the set. Now for the second part, you will be just querying the minimum value between 0 to x, and then checking whether it is greater than or equal to size. So that's how you solve this problem. Thank you everyone for watching this video. Please like if you got something from this video. Thank you.